All right, assignment 20, 5.5, completing the square. Your essential question, how do you use completing the square to write a quadratic equation in vertex form and or to solve a quadratic equation? Okay, so two questions here really. We're going to go back and we're going to use this completing the square, which you saw in geometry. We did this with circles so that we could put equations into the standard form of a circle. Okay, so we've done this, we did this last year. Possibly you also did this in Algebra 1. But we're going to use it this year to work with quadratic equations and to set up quadratic equations into vertex form. All right, so let me start with a little visual of what it means to actually complete the square. So there is a cool website. Not that one. Yes, that's a cool website. That one's mine. It's a cool website here. And we did a problem like this a couple of lessons ago where you kind of had to think about these are called algebra tiles. And this big square is an x squared. This rectangle here is a 1 by x, right? Because this is x by x. So this is a 1 by x. And then the yellow one here is a 1 by 1. So I'm going to take this expression, I'm going to do x squared plus 6x, and I'm going to complete the square on it. So I'm going to put an x squared out here, and I'm going to bring 6 x's out here. Okay, and my goal right now is to make these into a square. Okay, so to take these shapes and make a square. So let's see, what can I do here? I can line these guys up. Right now I've got a rectangle, right? So I can also, with this cool program, I can take and flip these guys around. So I'm going to try and flip that guy around. Oops. So I can do something like this. So far, no square, right? And what's really important is that, you know, this length here is an x, right? Because again, this square was an x by x. So the lengths have to line up. Okay, so I can only put, for example, something here that was maybe a 1 by 1, because that's the only space I have here. I can't put one of these x's there. Okay, but I can put this x, and maybe I should show you what I'm talking about. I can't put this here. It doesn't line up. Okay, I can put it here. So far I'm not having much luck forming a square. So even if I were to put this, let's flip that again. Oops. Or let me try it again. Flip it. Okay, there we go. And then this. So I'll put this here because I'm getting close to a square. The thing is that I have to be able to fill these in with ones. All right, well, to make a square here, let's see, I'm going to need a 3 by 3, right? So I'm going to need 9. Okay, and that is totally related to the 6. Okay, these 6 x's, I basically take that, divide by 2, that gives me 3, square it, and that'll give me the 9 ones that I need. So let's just see if we agree that this would make a complete square. So let's see. So do we believe that this is a square? So in order for it to be a square, all sides need to be equal, right? So let's see. This is a length of x plus 3. And then my height is also a length of x plus 3. That is, in fact, a square, right? It's a perfect square. So we just actually completed the square using algebra tiles. Okay, and again, that would be a length of x plus 3, a length of x plus 3. How do we find the area of this then? Well, you just take your x plus 3, times x plus 3, and you multiply that. Okay, and that's, if you do that, you're going to end up with a perfect square trinomial, which is pretty awesome. All right, so back to how do we actually use this? And why do we use this? Okay, so completing the square allows you to do a couple of things. Okay, first, it allows you to write x squared plus bx as a binomial squared. So let's take let me just show you what I mean. So I can take x squared plus bx, and I can add to it as I did in this last example. I took whatever was next to my x, and I divided it by 2, and I squared it. And so what I ended up with was really, remember that x plus 3 and x plus 3? Well, that's really x plus that b over 2 squared. So let's do that example that I just did. Okay, so for example, we started off with an x squared and 6 x's. So what I did then was I took that 6, the 6 x's, and I divided that by 2, and then I squared it. And when I was all done with that, remember my sides ended up with x plus 3 times x plus 3, right? Because really this ended up as x squared plus 6x plus 9. Okay, and x squared plus 6x plus 9 is really a perfect square trinomial. So it's your friend, let's see, it's friend number 3, a perfect square trinomial, okay, where this first term here is a perfect square and can be written as something squared. This last term here is a perfect square and can be written as something squared. Basically, I'm just taking the square root to get what I get in those parentheses. I can then take these two terms, multiply them together, and double it, right? 2 times 3 times x gives me, in fact, this 6x. So I know it's a perfect square trinomial, and when I factor this, I'm going to erase these equal sign. When I factor this, I get a binomial. I basically take the first and last terms, I take the sign that is right here before my b, and I squared it. So that is a binomial squared. Okay, so I just went from a perfect square trinomial and when I factor that, I end up with a binomial squared, or the square of a binomial. Okay, so that's pretty awesome. This is really helpful because right away now I know where my roots are. I know where my zeros are, and then I can figure out where my vertex is. Okay? Or, if you really want to have some fun with this, you can also write a quadratic in vertex form. And while we're not going to talk about circles right now, one thing that you learned in geometry is you could also use completing the square to write an equation with an x and a y to make that equation the equation of a circle in standard form. Okay. All right, so let's do a couple of examples together. So I'm taking these straight out of your book, and I will tell you what the actual problems are that I decide to do. And you don't need your book because I'm going to go ahead and write them out here as well. All right, so let's do some examples. So example 1, and this is going to be page 286, number 34. Okay, so there's some long directions here, and I'll go ahead and write them out. Find the value of c That makes the expression a perfect square trinomial. Then write the expression as a square of a binomial. Okay, so that's basically exactly what I did here. Right? So originally I had x squared plus 6x plus something. I had to complete the square. I had to do this process of taking whatever my b is, dividing it by 2, squaring it, and then I was able to write it as a binomial squared. Okay, so that's the most important part of this. Completing the square involves taking your b, dividing it by 2, and squaring it. So you gotta know what your b is. All right, so for number 34, the actual equation that we are given is x squared plus 26x plus c. Okay, so I am going to complete the square on this. So instead of having c here, I'm going to take my b, which is 26, I'm going to divide it by 2, and I'm going to square it. Now when I do this, I always like to write it out. One, so that you can see what I'm doing, and two, so that I can keep track of what I'm doing. So I'm going to have my x squared plus 26x plus, now I'm going to take my b, which is 26, I'm going to divide it by 2, and I'm going to square it. So this really gives me x squared plus 26x plus, now this is really 13 squared. Now whether or not you know what 13 squared is, and it is 169, you need to realize this is your perfect square. This is telling you, yes, this term is 13 squared. So that's that thing that goes inside the parentheses, right? And then this term is also a perfect square. Now together, again, if I multiply these together and double it, well, I end up with 26x. Well, 13 times x is 13x. Double it, I get 26x. Okay, so that tells me then that I can write this as a square of a binomial. So I should write equals, equals, equals. This is going to be my two square roots of these two terms. So x and 13. What sign am I going to take? Well, I'm going to take the sign of whatever b was. That gives me a binomial squared. And if you don't believe that this is the same as that, distribute it all out. And this will in fact give you x squared plus 26x plus 169, which is really what 13 squared is. Pretty awesome. Okay, let's do another one. So how about we do number 50? So page 287. This will be example 2. Page 287. We're going to do number 50. Okay, so, well, this one's an easy one. And then the next one I'll show you when you don't have a coefficient of x squared that's 1. So this is an example of the coefficient of x squared, or in other words, your a, okay, equals 1. So you're going to solve. Solve by completing the square. Okay, so solving this by completing the square. So number 50 is x squared plus 3x minus 1 equals 0. Okay, so when you want to solve these, it's important to, the first thing you want to do is you always want to get this so that it looks like ax squared plus bx, okay? Okay, so step one. Get into ax squared plus bx equals c. Okay, so we want to basically bring our c to the other side. So in order to do that, I'm going to get x squared plus 3x equals 1. Okay, step 2 is to complete the square. So this is the part where I take my b and I divide it by 2, square it, and add it. The problem is, notice now I'm dealing with an equation. Okay, before, these were not equations, these were expressions, right? This was an expression. There was not two sides. The equal sign is just because these are equal. But there was not two sides to this equation. Okay, now I started off with an equation, two sides. I'm going to keep it as an equation. So if I do something to one side of the equation, I must do it to the other side. Okay, so completing the square involves taking b, dividing it by 2, and squaring that. And that's what I'm going to add. And if I add that to one side of the equation, it's got to be added to the second side of the equation, or the other side of the equation. So I'm going to have x squared plus 3x plus, now this is going to be 3 over 2 squared. Okay, so I added it there. I'm going to need to add it to the other side as well. 3 over 2 squared. Okay, so over on this side, I'm going to simplify this. I know that this is going to be 9/4, okay? So x squared plus 3x, really, it could be left like that. You can simplify it like that. This is going to be, let's see, 4/4 plus 9/4. You'll see there's a reason why I'm doing it like this, because I'm going to end up taking square roots, and I want to make it as easy on myself as possible, especially if I'm not allowed a calculator. Okay, so I could have left it, though, like this, 3 over 2 squared, right? This really is 3 over 2 squared. And this side really is x squared. Okay, and if I take those, well, that's really 1.5 times x, double it, I end up with 3. That tells me that this is friend number 3, perfect square trinomial. Perfect square trinomial can always be written as a binomial squared. So when I factor it, two terms, the square root of the first term, square root of the last term. Sine of the b squared. And that's going to equal, let's see, 13/4. Okay, so now this takes us back to our last lesson. So I've basically got x plus 3 halves squared. And I want to get x by itself. I want to solve this. All right, so very easily I'm just going to square root both sides. So I'm going to have now x plus 3 halves equaling positive or negative square root of 13, and the square root of 4 is 2. Okay, so now I'm going to solve for x, so I need to subtract 3 halves from both sides. So I get negative 3 halves plus or minus root 13 over 2. You can leave it like that. You can also say, well, this is the same thing as negative 3 plus or minus the square root of 13 over 2. And that seems like a really good answer, and I would leave my answer like that. Realizing that this is two answers, right? One of them is where I add root 13. The other one is where I subtract root 13. And if you had to graph this, then you'd want to get decimal approximations. Okay? So let's see. I think I missed a step up here. I got so excited. So step 3 was to solve. Right? Because once you had it in this form with a square of a binomial equaling something, you could then just square root both sides. Okay, so that was a good example. Let's do another one. Get another sheet of paper here. All right, so example 3. I am going to do, again, page 287, but I'm going to do number 56. And this is where the coefficient of x squared is not equal to 1. So the coefficient of x squared, or your a, is not equal to 1. There is an extra step here that needs to happen, okay? So our example that we're doing is negative 3x squared plus 24x equals 27. I think I'm going to change this up a little just to make it a little bit more, have a few more steps to it. So I'm going to say instead of equals 27, I'm going to say minus 27 equals 0. Let's do that. I think you'll like this better. Okay, so first of all, we still are going to follow step 1. Okay, so step 1, you're going to make sure that you get it so that C is over here. Okay, so you want it to be ax squared plus bx equals c. Okay, so c is being brought to the other side. Okay, so that was the first step I wanted to show you, just in case if it's not already like that. So I'm going to do that. 3x squared plus 24x equals 27. So we're right back to where we started with, okay? All right, so here's the next step. This one's additional, okay? And that's because the coefficient, or the a, of x squared is not equal to 1. It has to be. Okay, so step 2 is going to be divide by coefficient of x squared. So you have to divide everything by that coefficient. So I'm going to rewrite this. Negative 3x squared plus 24x equals 27. Okay, we cannot have a being negative 3. It needs to be 1. Okay, so I am going to divide by negative 3 everything. Because if I divide this whole side by negative 3, every single term gets divided by negative 3. And whatever I do to one side of the equation needs to happen to the other side. Okay, so now I'm going to simplify that. So I get x squared minus 8x equals negative 9. Okay, now it's time to complete the square. Now that a is 1, or that coefficient of x squared is 1, step 3, complete the square. Okay, so that's basically where I take b, divide by 2, square it, and add it. I got to add it to both sides. Again, I've got an equation here, so it needs to happen on both sides. Okay, so I'm going to have x squared minus 8x plus, and again, try not to focus too much on these signs. If I take negative 8, divide it by 2, and square it, it's going to be positive. So I'm always adding my b over 2 squared. I'm going to do that on the other side as well. My b over 2 squared. Okay? All right, so simplifying this, I'm going to get x squared minus 8x. Now I have some options here. I can call this 64 over 4, or I can leave it as 8 over 2 squared. Okay, it's up to you. Your best bet is to leave this as a something squared, some number squared, because it's going to be easier to see. So actually, why don't I do this? I'll do this as 4 squared. I think I'm going to leave it like that. I think that will be a better way of looking at it. Now on this side, it's going to be negative 9. And again, it's, well, I took the harder way. 64 divided by 4, some of you guys will know that that's 16, but some of you won't. But everybody here will know that if I take negative 8 divided by 2, I get negative 4. I square that, I get positive 16. Awesome. All right, so is this a perfect square trinomial? In fact, it is. The first term is x squared. The last term is 4 squared. And if I take those two square roots, basically 4 and x, multiply them together and double them, do I get 8? I do. So I can write this side now as a binomial squared. First term is going to be x. Last term is going to be 4. Sign is going to be whatever b is. Add these together, I think I get 7. Okay, so now it's time to solve. So on this one, step 4 is to solve. So that just means I'm going to square root both sides. Okay, so I'm going to square root both sides. So I get x minus 4 equals positive or negative root 7. Okay, so now I'm just going to solve for x. So I'm going to add 4 to both sides. So I end up with x equals 4 plus or minus the square root of 7. Okay, so there would be 2 x-intercepts here. You can put it into a calculator to get an exact if you want, or to get an approximation if you want. But this is the exact. If we don't need to graph it, this is the way to give your answers. Okay, last one. So this one is going to be also on page 287. And I am going to have you do number 76. Okay, so the directions for this is to write the quadratic function in vertex form, identify the vertex. So write the quadratic function in vertex form. Identify the vertex. And the problem looks like this. Y equals x squared plus 26x plus 68. And let's remember that we're trying to get what vertex form is. So vertex form is y equals a, oops, it is y equals a, but before the parentheses, a times x minus h squared plus k. Now, I will tell you that for this assignment, all of your a's are going to be 1. Okay, so that's as difficult as I'm going to make it on you. So I'm making it a little bit easier than it really should be. Okay, but this way it'll challenge you to understand the process of completing the square without making things too complicated. All right, so in this scenario, notice how you have a y on the other side. Now you have a couple of options. You can bring this 68 over here with the y, so you would have y minus 68. And then you could complete the square, making sure that you add things to both sides, and be done. Or you could leave it here and just realize, hey, I'm going to move the c over, okay, because that eventually is going to be my k. Right? I'm going to probably have to add some stuff to it or subtract some stuff from it. Okay, but that eventually is going to be where my k is. So even if you brought it over here, eventually you're going to have to bring it back. So I want to show it to you in this, I'm going to show it to you not that way. I'm going to show it to you similar to the way that we did circles last year. Okay, what that is you group your ax squared and your bx. This is where you're going to complete the square. Okay, so I'm going to leave my y all by itself over there. Okay, I'm going to complete the square. So what I do is I keep my x squared plus 26x. And inside this group here, I'm going to also add 26 divided by 2. And I'm going to square that. Now I still have this plus 68 out there. Look what I just did. I just added 13 squared to this side, to the right side of the equation. So if that's the case, that means I need to also subtract 13 squared, or 169, from this side of the equation, because I didn't add it over here. Now you're more than welcome, again, you can bring that 68 over here, have that 169 over here, and then eventually bring it back over. But this is, I don't know, a little better way of doing it, I think, so you don't have so many steps. Okay, so now I'm going to write this as a binomial squared. So actually, it might be helpful if I simplify first. So let me simplify. Now remember, this is 13 squared. And then I've got negative 169 minus 68. So this is really a negative 101. Okay, so now I'm going to write this as a square of a binomial, because that's what I want, right? In vertex form, I've got a square of a binomial right there. So this is, again, this is x squared, and this is 13 squared. So those are my two terms. X, 13, take the sign of b. It's now in vertex form. So what is our vertex? Well, our vertex comes from the h and the k. So the vertex is going to be, now remember, vertex has a negative in front of it. So in order for this to be positive, that means that my vertex must have been negative. And we are done.